Okay, we are going to be doing the problems from the Chapter 4 sheet, and basically we are dealing with a system of equations. The problem number 4 and 5 in this video consist of two variables, x and y, with two equations. So we pretty much need to inspect algebraically what would work best. Since we already have y is equal to 2x minus 5, I want to take this 2x minus 5 and substitute it into the other equation. This will give us one equation with one unknown, and then we just solve for that unknown. The unknown here will be 4x. So we had 4x minus y equals negative 1. Instead of using y, we're going to use the expression that is equivalent to it, 2x minus 5. Now we solve. 4x minus 2x plus 5 equals negative 1. All I did was distribute this negative sign to get rid of the parentheses. Simplify. 2x plus 5 equals negative 1. Subtract 5 from both sides. 2x equals negative 6. And therefore x equals negative 3. Okay, one down, one to go. Now that we know that x is negative 3, how do we find y? Because we need a pair. We need an ordered pair. We can go back to either of these equations to solve for y, but since that second one is already set up for me, I'm going to use that one. Y equals negative 6 minus 5. Y equals negative 11. I think I'm done, but I need to make sure that I'm done. I'm going to check both solutions. The solution in both equations. Let's check the first one. 4 times negative 3 minus negative 11 equals negative 1. This was 4x minus y equals negative 1. I just substitute negative 3 for x, negative 11 for y. I get negative 12 plus 11 equals negative 1. This side, negative 1 equals negative 1, and that is correct. The other equation is y equals 2x minus 5. Y is negative 11 equals 2 times negative 3 minus 5. Negative 11 equals negative 6 minus 5. Simplifying that, that is negative 11. This is negative 11, and that checks. So the solution is negative 3, negative 11. We used substitution. Question number 5. Get you lined up. Question number 5. 10x minus 2y equals 5. 2/5 y equals 2x minus 1. Okay, it's almost set up for substitution, but not quite. I'm not liking this 5 down here. I think I'm going to, let's see, y, the first thing I have to do with y is double it. I'm not liking what I see. If I don't like it, I can change it. I'm going to multiply this entire equation by 5. What that will do is I will multiply every single term on both sides by 5. This is my problem. So I end up here with 2y equals 10x minus 5. 5 times 2 is 10. 5 times negative 1 is negative 5. Okay. I'm not too crazy about this one, but let's divide by 2. What I do to one side, I have to do the other. Now I have y equals 5x minus 5 halves. I'll leave it like that. I will use substitution again, where I will use this expression for y and plug it into the other equation. It's important you go back into the other equation. So we have 10x minus 2y equals 5. Let me use, instead of y, I'm going to use 5x minus 5 halves. It's an improper fraction, but I'm going to leave it that way. Let's see what we get. Now, one equation with x, just x. I can solve for x with one equation. Distribute, ooh, wait, whoa, what's going on here? I know it's going to be positive. 2 times 5 over 2. Those are going to cancel. That is going to reduce to 5. But here's my concern. How many x's do I have left? I don't have any x's. They drop out. So I can't solve for x. Something's going on. Question is it going to end up in a true statement or a false statement? These simplify to 0. This simplifies to 5, and the other side is 5. So 5 equals 5. No x's. I was trying to solve for x. Didn't happen. This is a true statement. Which means that these are actually the same equation. They just don't look the same. We have a dependent, equations, infinite solutions, however, it's not just any old solution will fit this. All the solutions are the set of all x such that, okay, use the first equation, 10x minus 2y equals 5. The, set of all, they're not x's. They're the set of all x, y points such that this relationship holds. That's my set of infinite solutions. And that's how you write it.